Hi guys, and welcome to Module 8 where we talked about percents. A percent is a ratio that compares a number to 100, and the symbol percent is used to show a percent sign. So for example, a percent can be written as a fraction. Percents are always out of 100, so 17 over 100. You can write it in word form, 17 to 100, always comparing it to 100. And you can also write it in ratio form, 17 to 100. In this slide, we are going to rewrite the ratios to show percents. So we're going to compare the ratios to 100, and we will determine the free throw average for these players. So player 1, his average is 17 out of 25, and if we wanted to find that as a percent, 17 to 25, again, percent is always out of 100. So to get from 25 to 100, we know we're getting bigger, so we multiply by 4. And what we do to the denominator, we must do to the numerator. And 17 times 4 is 68%. For the second player, we have 33 free throws out of 50. Percent is always out of 100. We're going from 50 to 100. We know we're getting bigger, so we multiply times 2. And 33 times 2 is 66%. And lastly, the player 3, his free throw was 14 out of 20. Again, percents are always out of 100. So to get from 20 to 100, we do times 5. And 14 times 5, let's do it over here. Zero. Player 3 had an average of 70%. This slide is a really important slide. When you took notes in your spiral about these, this is very, very important for you to be able to look back and review. The first thing that we discussed was writing fractions as percents, and we just went over that. When you write an equivalent fraction and make it a percent, you always want the denominator to be 100 because anything over 100 is a percent. The next thing that we learned is writing percents as decimals, and the first thing that you would need to do is remove the percent symbol and then move the decimal point 2 places to the left. And the reason that we're doing this is because we're getting smaller. We're actually dividing. So we can think about that by decimals with the letter D, divide with the letter D. We're going to the left 2 places. And lastly, when we're writing decimals as percents, we just move the decimal point 2 places to the right because we're getting bigger, and then we add the percent symbol. And the reason that we move 2 places is because we base percents out of 100, and 100 has 2 zeros. In class, we discussed patterns on completing this table, and we talked about common percents. And we should know when the denominator is 5, we are counting by 20s. So 1/5 is 20%, 2/5 is 40%, 3/5 is 60%, 4/5 is 80%, 5/5 would be a complete 100%, and 6 to 5 is an improper fraction, showing that you are over 100% and you're at 120%. You could write the fraction, for example, 1 to 5, and knowing that we're always trying to get to 100, multiply by 20, and that's how we end up with 20 over 100 or 20%. Now, we also talked about thinking about this like if we took a test that had 5 questions. Each question is going to be worth 20 points in order to get to the 100. So if, for example, we answered 3 out of the 5 questions correct, on our test, we would get a 60%. In class, we also talked about how to turn a percent into a fraction and a decimal. And the fraction we want it in simplest form. So for example, if we have 35%, we know that percents are always out of 100. So we go 35 over 100. we think about the GCF, for the greatest common factor, between 35 and 100 in order to get this fraction in simplest form. So the GCF between 35 and 100 is 5, and 35 divided by 5 is 7, and 100 divided by 5 is 20. So the fraction form for 35% would be, in simplest form, 7 over 20. In decimal form, we talked about how to turn a percent into a decimal. We said to remove the percent sign, and since we're getting smaller, we go ahead and we turn that and we move it 2 places to the left. So it would be 35 hundredths. We also talked about representing percents and decimals and fractions from a hundredths grid. And so in this example, we have 1 full hundredths grid shaded in, and we have 10, 20, 30 hundredths of another. So what this means is that for the decimal, for example, we have 1 whole and 30 hundredths of another. As a fraction, this would be 1 and 30 hundredths, and we know that we can simplify this. We can use our trick by canceling out 1 0 with the numerator and 1 0 with the denominator. So the fraction in simplest form for this diagram would be 1 and 3/10. In percent form, we know that in order to turn a decimal into a percent, we just move the decimal point over 2 times to the right, and so this shows 130%. What happens when we have to write a fraction and convert it into a percent, but the fraction does not have a denominator that's a factor or multiple of 100? In this case, we would have to use long division, and we're going to see an example of that in a couple of slides. So let's take a look at this example. We have 96 out of 200 animals treated by a vet or horses, and they're asking us to write 96 over 200 as a decimal and as a percent. So what we want to do is we're going to first write information that's given. So 96 out of 200, and we have to turn this into a percent. Well, we know that percents are out of 100. So to get from 200 to 100, we are getting smaller, so we're going to divide. 200 divided by 2 will get me to 100. 96 divided by 2 is 48. And so now that we have it set over 100, we know that the percent is 48%. And we were asked also to write this as a decimal. So we know to change a percent to a decimal, all we have to do is remove that percent sign and move my decimal point over 2 places to the left. So in decimal form, it would be 48 hundredths. Here is a perfect example of a fraction that the denominator cannot easily be turned into 100. They tell us here that 1/8 of the animals treated by the vet are dogs, and they want us to write 1/8 as a decimal and as a percent. So again, I'm going to write the information given, which is 1/8. And unfortunately, there is nothing that I can multiply a whole number times 8 that'll get me to 100. So in this case, we discussed this fraction bar meaning divide, and we know that the denominator is the D, the dog that goes outside, and the numerator is the one that naps inside. So now we see that 8 cannot go into 1, any whole numbers, so we know we're going to talk about decimals. So we start adding our decimal point and adding zeros. 8 goes into 10 1 whole time. You take 8 from 10, and that gives me 2. Keep adding zeros until we reach a terminating decimal. So 8 goes into 20 2 times. Take 16 from 20, and that gets me 4. Keep adding zeros. And 8 goes into 45 times exactly, evenly. So we have 125 thousandths as the decimal for 1 to 8. And we're asked to turn that also into a percent. So percent means that we're going to move it 2 times to the right. And so our percent would be 12.5%. These were sample questions that we got from our homework for lesson 8.2, and we were asked to find the percent of each number. And so I spoke to you guys about how we can find the percent of each number, either the fraction way or the decimal way, and it is up to you to decide which way you feel most comfortable. We're going to do the first one, and the first one is asking us to find 25% of 56. So I'm going to go ahead and I know that 25% as a fraction, and I'm going to do the fraction way first, is 1/4. That is equivalent to 25% of, always means times, 56. And so I'm going to set that over 1. I'm in familiar territory now because now I can simplify. 4 will go into 56 14 whole times, and so 25% of 56 would be 14. That was the fraction way. Let's go ahead and do the decimal way. The decimal way says I'm going to turn that percent into a decimal, so I'm going to say 0.25 of means times 56. If I multiply 56 times 25, I'm going to get 1,400, but I can't forget to move my decimal point over 2 times. So either way, whether we do it the fraction way or we do it the decimal way, we end up with 14. Let's take a look at find the percent of each number. We talked about 55% of 900, and we're going to go ahead and do the fraction way first. So 55% really means 55 over 100 of means times 900 over 1. This is excellent because I can simplify the 100 and the 900, and 55 times 9, 4, that's 495. And so that was the fraction way. If we went ahead and did the decimal way, we would go 55 hundredths of means times 900. I would do 55 times 9, which is the 495, add the 2 zeros, and then don't forget to bring over the decimal point. So I still end up with 495. For some, you will notice that the decimal way is easier. For many, the fraction way is easier. I think these two proved that the fraction way was much, much simpler. The last thing I wanted to talk about here is notice how it says check whether your answer is reasonable. The only reason that, and I told you guys not to worry about that, but I did want to discuss that in this slide because this all it was talking about is if we are estimating and we estimated 55%, for example, that's really close to 50%. And 50% of, and then we estimated 900 to be really close to 1,000. So 50% of 1,000. That is really simple because we can go ahead and determine that 50% of 1,000 is 500. Because what's half of 1,000? It's 500. So even though I asked you guys not to do that, I did want to discuss that in this slide because that estimating power helped us to determine that, hey, my answer is going to be really close to 500. My answer was actually 495, so I know that I was super close and I know that I must be right. When we have a question like this where we are given decimals, percents, and fractions, and in this case, we have a bookstore. We have 3/10 of the shelves holding mysteries, 25% of the shelves holding travel books, and a fraction of 7/20 of the shelves holding children's books. Which type of book covers the most shelf space in the store? I loved how you guys, what you guys did in class was you turned these all to percents. And so what you asked me to do was to rewrite the decimal, the percent, and the fraction. And then you guys suggested let's turn them all into percents. So in order to turn this first decimal into a percent, we know to move it 2 times to the right. And so this is really 30% of mystery books. 25% is already given as a percent, and those are your travel books. And lastly, you turn 7/20 into a percent. We know percents are always out of 100. So we know we have to go times 5, and this is 35%. of children's books, and which type of book covers the most shelf space, and you determine that was the children's books. In this slide, we will review finding the percent of a number. If you were asked to find 20% of 60, for example, we talked about how we can turn that percent into either a fraction, so 20% we know is 1 to 5, of means times, and then 60. So we can go ahead and do the fraction 1 to 5, or 20%, of 60, and then we can simplify. We know that 5 goes into 60 12 times, and so the answer is 12. We also talked about how we can turn that percent into a decimal. So we know that we can turn it into a decimal by moving it over 2 times to the left, and so that really becomes 2/10, or 20 times 60. And if we multiplied 60 times 2/10, we can just do 60 times 2, and that'll get us 120, but we can't forget about moving that decimal point over 1, and so the answer is 12. We also practiced some of these in class. We said let's find 25% of 40. I think the easiest way to do this one is turning the 25% into a fraction, 1/4, of means times 40, we'll set it over a fraction. We now can simplify. 4 goes into 40 10 whole times, and so 25% of 40 is 10. We'll do the same thing with 60% of 150. We can set this over a fraction. As a matter of fact, I think it's easier to, set this up as a fraction, but in simplest form. So the easiest way we could do this is 3 to 5, which represents 60% of 150 over 1. Because now we can simplify. Now we can say 5 goes into 150 30 whole times, and now you're just left with 3 times 30, which is 90. Had you done the decimal way, or had you set this over 60 over 100 times 150 over 1, that still would have worked. The goal here is to try to find the fraction or decimal that's going to make it easiest for you to find the percent of the number. For example, we have 75% of 32. Well, I know that 4 is a factor of 32. I also know that 75% as a fraction is 3/4. So the easiest way for me to find 75% of 32 is to make 75% 3/4 of means multiply, set 32 over 1 as a fraction. Now I can simplify because 4 goes into 32 8 whole times, and 8 times 3 is 24. Another example here, we're given a sports store received a shipment of 400 baseball gloves, and 30% were left-handed. So they're asking me how many left-handed gloves were in the shipment. Well, we can do this either the fraction way or the decimal way. Let's go ahead and do the fraction way first. So the fraction way, 30%, percent is always out of 100, so it's 30 over 100 of means times 400. The fraction way is actually really simple. 100 goes into 400 4 times, and so 30 times 4 is 120 gloves from the 400 baseball gloves were left-handed. We can also do the decimal way, which is 0.30 or 30 hundredths of means multiply 400. Now we can go ahead and multiply the 3 times the 4 is 12. I'm going to add 1, 2, 3 zeros, but we can't forget to move that decimal point over twice, and so my answer is still 120 gloves out of the 400 glove shipment were left-handed. Let's go ahead and try another. 28% of 25. I actually think that I'm going to make this the fraction way. Let's do 28 over 100 of means times 25, set it over 1 as a fraction. We can simplify. 25 will go into 104 whole times, and so we're left with 28 divided by 4, which is 7. That was very simple. The decimal way, we're going to take 28 hundredths and we're going to multiply it by 25. And if we do 28 times 25, we're going to end up with 700. But we can't forget to bring that decimal point over 2 places to the left. And so our answer is 7. This was a really important lesson that we learned when we talked about percents in Module 8. We talked about the formula for finding the percents given a part and a whole. So we talked about the formula being the part to whole times percent always is out of 100. I also introduced you guys to a different formula which represents the same, but you guys seem to prefer the is over of times percent over 100. Regardless of whichever one you use, all you need to do is plug in the given information, and that will help us solve the problem. So in this example, we have 22 students is, so again, we're going to just plug in information that's given. Percent of 55. Well, we do know the is, we know that 22 students is, so we're going to go ahead and plug that in. We do know the of, because they give us 55 as the total whole amount of students. What we don't know is the percent. So that is our unknown, and we talked about that being x in algebra because we don't know what it is, and that's what we're solving for. And percent is always out of 100. So we also talked about how at this point we're going to cross multiply. So we have 55 times x, which is 55x, is equivalent to 22 times 100, so we're just cross multiplying, which would be 2200. Lastly, our last step is to solve for x. So we're going to go ahead and divide by 55, and that way we can isolate x, we can cancel that out, and now we have x equals. We're left with 2,200 divided by 55, so I'm going to go over to the side here and do 2,200 divided by 55, and 55 goes into 220, is that 4 times? Yes. And don't forget to bring up that last 0. So the answer here is 22 students is 40% of 55. Using that same formula, so I always ask you guys to write the formula first, and that way it'll help you plug in the numbers. So is over of times percent over 100, and now we have to determine what information is given and what is it that we are solving for. So 24 red marbles is, so we know the is, so we go ahead and plug that in. 40% of marbles. We don't know the of, so that's what we're solving for, so that's our x. We know the percent is 40%, always over 100. So now we are at the cross multiplying step, so x times 40 is 40x equals 100 times 24 is 2400. We now want to figure out and solve for x, so we isolate x by dividing both sides by 40. That way this cancels out and x equals, let me do some canceling out of zeros. This 0 can cancel out with this one. I'm left with 24 divided by 4 is 6, and don't forget that other 0 there, so my answer is 60. Does this make sense? 24 red marbles is 40% of 60 marbles. Absolutely. That's my answer. Although you can use the is over of times percent over 100 for this question, this is a percent of a number question. So for this one, I'm going to want to just do the decimal form. So I can do 15 hundredths of $9. And I go off to the side and I do 15 times 9, and that is 135. But I can't forget to bring over my decimal point 2 times, and so my answer is $1.35. So 15% of $9 is $1.35. What if you wanted to use the formula for this one? You absolutely can, and let me show you how you can. 15% of $9 is, in this case, your is your X. You don't know it. You do know the of, it's $9. You do know the percent, it's 15, always out of 100. So for this one, we're going to cross multiply. We determine that 15 times 9 is 135 equals 100x. And we're going to divide by 100 in order to get x by itself. So x would be 1 whole and 35 hundredths, which is the same as $1.35. Okay, let's use the formula here once again. We have the is over of times percent over 100. So again, this formula is perfect for solving percent problems because whether they give you the is or the of or the percent, they will give you enough information where all you have to do is solve for x, the unknown. So 12 is so we do know the is. Of 200, we do know the of. We don't know the percent, that's the unknown, so that's our x. Let's go ahead and make that x. Always out of 100. And so now when we cross multiply, we have 200 times x is 200x equals 12 times 100 is 1200. We're going to isolate x, so that means we're going to divide both sides by 200, so we can cancel this out, and x equals, I can do some simplifying here. I can cancel out to some zeros, and so I have 12 divided by 2 is 6, and the answer is simply 6. I wanted to go over this problem with you guys once again because sometimes we tend to overthink problems. And for this one, we could, again, use the is over of formula, but we really don't need to. In this one, we have, out of the 25 students in Mrs. Green's class, 19 have a pet. What percent of the students in Mrs. Green's class have a pet? So what we can really do is we can set this up as a ratio. We have 19 students out of 25 have pets. They're asking us what percent, so obviously we know that we're trying to get to 100. 25 times what number is 100? That's 4. And so off to the side we do 19 times 4, and that's 76 out of 100, which means that 76% of the students in Mrs. Green's class have a pet. I hope you enjoyed our review of Module 8. If you have any questions, please feel free to ask.